Hello, my topic today, digitalization in welding. In many areas of, say, technical applications, digitalization is state of the art. But today I want to focus on how is the state and the development in the welding field. Let me first explain that we do not talk about the welding processes themselves. Of course, there have been a lot of developments in the last years. There is a controlled short arc, there is an even better pulsed process, there is a spray arc with even higher penetration, but these are all like incremental improvements. And of course, in the background, in the power sources itself, there is a lot of digital processes running. But we want to go to a level above. We want to talk about digitalization of the welding process in the area of manufacturing. So how do we start? Of course, the starting point is always in digitalization, you need data. So we need to measure and collect data, and by analyzing them, create valuable information, because that's digitalization. I want to give you 4 examples what you can do with digitalization in welding. What's state of the art nowadays is consumption data. So you collect wire and gas usage, you measure the electrical parameters, and by this you can detect energy consumption, wire and gas consumption. Nearly every welding data management system does that. If you combine this for various working places or for various robotic cells or even a complete robotic welding manufacturing, then you can compare the different areas, and of course you can there then get productivity data. Also quite state of the art. What's not so commonly used is to get quality data. And what's still in development, but I'm sure will come, is the detection and measurement of the CO2 footprint during welding. So let me focus on these 2 latest things. Quality data in welding. How do you proceed here? So what you do is that you collect the electrical data during the welding process, and you need in parallel some investigations about the quality of the welded parts. And then you know if you have a deviation in these electrical parameters, for instance the amperage, you know exactly, okay, if I leave a certain level of confidence, then I might get quality problems. And of course then you can set the parameters that the welder or the robotic operator gets a warning signal that he is leaving a certain parameter window. So that's also possible and available today. What's still in development is detection of the CO2 footprint, but in my opinion it's the next logical step. If you anyway measure all the consumption data, then you can do that step. But it's important that you have really all the components that are in a working place or in a robotic working cell. That means you also have to measure the energy usage of the robot itself, of a fume extraction unit, and so on. But having all this consumption data, then you can get access to data banks, which are, at least in Europe, available. And by this you can calculate the CO2 footprint of a welded component. That means you can tell your customer, okay, welding this component, this created X kilogram of CO2 equivalent, and that's a valuable information that's needed more and more. So I hope with these 4 examples I could explain how digitalization in welding offers new chances and new application areas. Any questions for the Weld Prof? Please contact me.